Okay, so today we'll be talking about exponential and logarithmic equations and how to solve for them. Okay, so exponential equations, that is where the x is in the exponent, and you have to solve for it. Okay, all right. The logarithmic equation is basically where the x is in the log. Simple as that. So what you have to do is be able to use some methods to actually go through it. So first type of method is change all the bases to be the same. Now the bases is the number below the exponent. So for example, if I had 32 raised to the 4x power, and that equals 8. Yeah, let's just leave it at 8. How do I find out what x is going to be? Okay, so what I'm going to do is I'm going to change both of these numbers to have the same base. And some of you guys are probably going, oh, I already know that. And some of you guys are going, what are the same bases? Well, if you remember, 2 to the 5th is 32. And 2 to the 3rd is 8. So I'm going to change this right side to be equal 2 to the 3rd. Okay, and I'm going to change the left side to be 2 to the 5 times 4x. Okay, now that's all going to be crammed into the exponent. You'll understand why in a second. Okay, so this becomes 2 to the 20th x equals 2 to the 3rd. Now if I have two numbers that are equal to each other, in other words, if I have two numbers that have the same base and are equal to each other, then their subsequent exponents have to be equal. So in other words, I can rewrite this with the x outside of the base, or outside of the exponent. So 20x equals 3, okay, and x has to be 3 divided by 20. And there you go. You actually have it. Now, do you have to plug it back in and check it out? Yeah, that's probably a good idea. Take it and plug it back in. The one thing that you need to understand is that you can have negative exponents, you just can't get negative answers from it. So just understand, as long as you do it that way, you should be good. Alright, if you don't have the same base, now obviously the last one, what we just did was you want to just change the bases all to be the same. This is the easiest method to do, because if you get the same base equal the same base, the exponents are the same. Simple as that. But if you don't have the same base, change it to a log problem. Okay, so this is the base, this is the exponent, and this equals the answer. So when I change it to a log, it's going to be log base 14 of 300 equals 2x. Okay? Alright, well, I don't know if you know this, but you can use change of base, log of 300 divided by log of 14 equals 2x. Okay? Now, if you take a look at this problem, shoot, all I have to do is divide by 2 and I'm done. Technically, you don't even need to find that log. And voila, you actually have your answer. So parentheses log of 300 divided by log of 14, all divided by 2 is equal to x. Now you can go ahead and calculate that out, and I'll show you what that is going to be in a sec. Okay, so you do log of 300, what was it? I just forgot it. Oh, divide by log of 14, just forgot it. And then you're going to divide this whole thing by 2, and you're going to get 1.081. Let's leave it at that. Alright, and that will be your answer right there. Or you could just leave it as this. They're both equivalent. That's the really cool thing about it. Alright, now this one is going to be a logarithmic problem. So if you have just one log, change it to an exponential problem. So let's say we have log of 3x minus 5 equals 7. Something like that. Well, 1, 2... Yeah, there we go. No, let's change that to 3. It's going to be a little bit big if we go that big. Okay, now right now this is a base 10, so you could type a 10 in if you want. It's common log. Okay, so the base is 10, the exponent is 3, and the answer is 3x minus 5. So if I change it to exponential form, I'm going to have 10 to the third equals 3x minus 5. All I'm doing is changing it to that form. We learned that back in the properties of logs, that you can just easily change from one form to the other. Okay, now what does this become? This becomes 1,000 equals 3x minus 5. Obviously this becomes 1,005, which equals 3x, and then you divide by 3. So 1,005 divided by 3 is equal to x. You're going to get some funky looking numbers is what I'm saying with this stuff. Okay. Alright, now if you have more than one log on one side, contract it and switch to exponential. So let's say we have the log of x minus 3 plus the log of x, and this is equal to 1. Okay, so I'm going to contract it by, remember, you're contracting, it's addition, but we are going to be timesing these two. Okay? So I'm going to contract it to be log of parentheses x squared minus 3x parentheses equals 1. Okay, now remember the base is 10. If you have to write it out, please do. If there's no base, there's a 10. If there is a base, know what it is. And so exponential form is the base with the exponent is equal to the answer, which is x squared minus 3x. Okay, voila. We actually have a system. Now this is going to have to be solved quadratically. So it's going to become 0 equals x squared minus 3x minus 10. Okay, and then you're going to have to factor it. So 0 equals, what is it? X minus 5, parentheses, x minus, or plus 2. Okay, so that means that x is equal to 5, comma, negative 2. Okay, now when you get your answers, we haven't been doing it the last couple times, but you need to plug it in and check. The reason why I haven't been plugging it in is because I've had positive answers. And positive answers, when you plug them in for exponents or logs, you tend to be very off very well. Okay, now if I plug in 5, this is going to be 5 equals 5 minus 3 in here is going to, in this you can do subtraction in here, you just can't do subtraction between the two logs. So 5 minus 3 is 2, and then this becomes 5. Okay, and so we just minus it out and we just do the timesing, so it becomes, what it actually becomes is this. Here, if we plug in the 5, we get log of 2 plus the log of 5 equals 1. Okay, now remember, I don't add the exponents. I don't add the 2 and 5. I multiply them. So it becomes log of 10 equals 1. Well, guess what? The base is 10. This number's 10. That's actually a true statement. Now, if I plug in a negative 2 up here, I'm going to go negative 2 minus 3. That's going to be negative 5. That's not good. You can't do the log of a negative number. Even if you try it on Desmos, it's not going to work. So right off the bat, negative 2 is not even part of my answer. It's just going to be 5. All right, and the last one about equations. If you have multiple logs on both sides, contract both sides down to 1 log each and then solve, and you'll see why. Okay, so if I contract this side, it's going to become log of 9x, and this side is going to become log of 10 plus x divided by 2, because remember, you're dividing it in there. Okay, and you can put another set of parentheses in here if you like. Okay, now here's the cool thing. Just like with the exponents with the same base, if you have two logs that are equal to each other, then these two subsequent numbers are also equal to each other. So I can set up the equation where it's just 9x equals parentheses 10 plus x divided by 2. Voila. Now I can multiply both sides by 2 and I get 18x equals 10 plus x. Okay, I minus x from both sides, so I get 17x equals 10, and then I divide by 17 and I get x to be 10 over 17. Now the reason why I'm not going to check this one is because this is positive, and because when I plug it into these two spots I'm probably going to get a positive answer, so that actually checks out. You can do it, you can work with it and actually work across to get the answer, but I'm pretty sure you're going to get the same answer as before. And my guess is you would probably get log of 90 over 17 on both sides. Okay. All right. So that's it for solving logarithmic and exponential equations. If you just follow those steps, you should be set in steps 1 through 5. And start at 1 and work your way down until you get to the right one that fits the right equation. Okay. Thank you guys. Have a great day. Bye.